students. Today we are going to discuss about remaining topics in the trigonometrical leveling. Right? So this trigonometric leveling, we already know that it is going to involve in the taking of the angles. Right? It is going to take angles and distances, and we are going to calculate the level, or we can call it as reduced level. Okay, or we are going to calculate the elevation. Right? So by using these angles as well as the horizontal distances, we are going to find out the levels. That is called trigonometric leveling. Right? So in this trigonometric leveling, we are going to use the theodolite. Okay, so we know that we are going to use the theodolite to take the readings of angles. To measure the distances, we are going to use tape or chain. Right? We are going to use the tape or chain for the taking of horizontal distances. Right? So with help of these two, we are going to know the level difference or the elevation, the reduced level of a particular object without set up a leveling staff at the object. We are not going to set up any leveling staff, okay, level staff at the site of object, right? So but we are going to know the elevation, right? So that elevation is calculated based on the theta, that is angle taken from the station, that is theodolite, and the distances measurement. Okay, sometimes we can have this distance measurement, but sometimes we can't have the distance measurement also, right? So we will see those cases. Already we know, right? The base of the object is accessible, and second case is the base of the object is inaccessible, right? So totally here we are having the three cases. Okay, we are having the three cases in the trigonometric leveling, right? Next, we already saw the case one. Okay, where the base of the object is accessible, right? So we already saw the thing. Okay, so here we have an instrument. Okay, so the instrument station is P. Okay, so from here, first of all, you are going to keep your leveling staff to know the height of instrument. Okay, we are going to keep the leveling staff near the benchmark, and we find out the value. Then based on this, we are going to calculate the height of instrument heads, right? And also we calculate the distance between this instrument station to the object, right? That is D. Okay, so this is the value of D we calculated, and we are going to make it a level line, right? So last case we took it as Q, and this is as Q dash, this is Q1. Okay, so like that, from this reference we are going to cite the point, okay, Q, and we calculate the theta. Okay, now from this triangle we are going to find out this height, right? So that is the actual procedure in the trigonometric leveling. Okay, from the delta CEF, right? So H is given as, that is FE. Okay, so FE means this. Okay, from here to here. Okay, this is given by, right, D into tan theta. So from this triangle, what you did now? So tan theta is equals to, okay, tan theta is equals to, right, FE by, okay, CE here, but CE is given as D. Okay, so FE is equals to D tan theta. So FE would take it as taken as the small h. So FE is equal to small h. This is equals to D tan theta. Now finally the RL of F. Okay, so he is going to calculate with the help of two things. One is RL of benchmark plus the reading, the backside which is took on the benchmark, plus this H value is going to give the reduced level of a point F. Okay, otherwise you can take the like this. Now instead of H we are going to substitute the D tan theta. So finally the RL of point or object is given is equals to RL of benchmark plus staff reading over the, that is back side, over the benchmark plus d tan theta is going to give the RL of f. This is the first case we saw in the last class. Okay. Now we are going to see the second case, that is case 2, where the base of the object is inaccessible. The base of the object is inaccessible. Okay. So third case also the same thing, but we'll see the difference. Okay. So why it is inaccessible, right? Why the base of, this is the base of the object. Okay, this is the base of the object. It is inaccessible. We can't able to measure the distance between these two. Okay, from the instrument station to the object. Right? Okay? So sometimes there may be some obstructions. Okay, so because of due to the obstructions. Okay, so obstructions like river. Okay, pond. Okay, some wetland will be there. We can't able to. Some water body is there. We can't able to measure over the river or pond with help of chain or tape. Okay, but we need to know the level difference of that particular object from the another side of the river, right? So one side object is there, one side we are going to, if we are taking a river, right? This side object is there, this side instrument has to keep, and you have to find out the values. Okay, in this case, this case is applicable, right? So whenever it is the base, we can't reach to that particular place, that is called inaccessibility. So in that case, how to find out this? What we can say? Levels. Okay. So now in this case 2, we have another 2 cases, right? The first case is instrument access at the same level, right? Instruments are accessed at the same level, right? So if you see here, this is the benchmark. Here we set up the instrument at a point O1, O2, and we have another thing O1, right? O1 and O2, 2 stations. That means first of all we are going to set up the instrument here, right? So while setting this instrument, if you are seeing the for the back side over the benchmark, it will, the value will be the yes, same. Okay, so that's why from here, right, from here we are going to sight the object and we are going to note down the value of theta 1, right? Next time the instrument is shifted O1 to O2, right? So then it will be at the same level. You can see if you are changing any point on this line, they are all at the same level, right? So from here you are going to see the theta 2 value, but we don't know these values. Okay, the d value we don't know here, and the h value we need to find, but we know the distance between O1 and O2, that is small d, right? So we will see how we are going to proceed with this. Okay, so without knowing d value, without knowing h value, but we need to find out the h value, right? In the previous case we know the d, but here we don't know the d value, right? So based upon these two similar triangles, we are going to solve and we are going to find out, right? So if you are familiar with the trigonometrical formulas, it will be very easy, right? So from the first point, first triangle, right? The first triangle, no? From the position O1 to, right, AF. Okay, F will be there, A will be here. So this is theta 1, and the second triangle is there from O2, right? From O2. So see the first triangle. Okay, so this is the D, and for second time we will get small d plus capital D. Okay, so you can see here, if we are taking first triangle, if we are taking the first triangle, okay, this is the first triangle, here we have D, and if we are taking another triangle, no, here we have D plus D. Okay, so now we will see. So from here the first triangle it is D tan theta 1, and from the second triangle, right, we have h is equals to d plus d tan theta 2, right? So by solving these two, we are going to, from these equation 1 and 2, right, d tan theta is equals to d tan theta. How we are going to equate, since this h is same, okay? So that's why these two are getting equated, right? So by solving this, we are going to find out the RL of that particular object. Okay. Now d tan theta 1 we can take, from here also we will get d tan theta 2, Okay, that's why they are bringing to one side, and we are making d out of that, and we are going to get d into tan theta 1 minus tan theta 2. Okay, so remaining d tan theta 2 will be there in that side only. Okay, now to find out the d value, okay, d is equals to d tan theta 2 divided by tan theta 1 minus tan theta 2. Okay, now we are going to the our equation, that is RL of f is equals to RL of benchmark plus staff reading on the benchmark plus small h, right? So h is given by which formula? D tan theta, but d value is this. Okay, we are going to substitute that h value as h is equals to d tan theta 1. Okay, so instead of this small capital D, we are going to substitute this formula, that then we will get small d into tan theta minus 1 into tan theta 2 divided by tan theta 1 minus tan theta 2. Okay, so if you are substituting in this equation, we are going to get the RL of f. Okay, so if you solve this equation again, so we will easily understand this method, and we can calculate easily the RL of that reduced level of a object f. Okay, so next we will move to next case, that is second thing, instrument axis at the different levels. In the previous case, we are having the at the same level, but here one instrument station will be one location, another instrument will be another location. Now, depending upon the ground conditions, again in the second condition we have again two cases. One is the instrument axis at O2 is higher than O1, right? So O2 will be at higher case and O1 at the lower level. Okay, so in this case, what we have to do? Okay, let us see. See here, this is O1 initial station, O1 at lower level and O2 at the higher level. Okay, so what we are going to get? We are not going to get same values of height of instrument. The height of instrument is going to change from point to the another point, right? So similar things. The distance between these two stations is small d, and from first station to the object is located at d, but we don't know this value. We have to find out this. Then only we are going to calculate h2 and h1, right? To calculate this. Okay. So terms will be the same. If you set up the instrument at O1, if you are taking the value at benchmark backside, it will be S1. If you shift the instrument to the O2, then you are going to get the value on the staff. Okay, leveling staff S2. This is height. Based on these two values, we are going to calculate the what is called the height of instrument H1 and H2. Okay, so now we set up the instrument firstly at O1, and we calculated the we sight the leveling staff near the benchmark. We are going to get a value of S1. Okay, now we sighted the point P and noted down the value of angle theta 1, right? Theta 1. Then we shifted the instrument to the O2, and we say again we took the reading on the benchmark. We got the S2. Then if you sight it towards the F, we are going to get a angle of theta 2. Okay. Now based on these values, how we are going to measure the we are going to calculate the RL of point F. RL of point F. We are going to calculate this. Okay. Now we will see one by one. Now here H1 minus H2 is equals to S2 minus S1, that is equals to S. Okay. So this is the condition we are going to take, but H2, the difference between H1 minus H2, we can see here the difference between H1 and H2 is this value. This will be same equals to the difference between S1 minus S2, and this we are going to take it as S. Okay, so that is the thing. Next, from the first triangle, we are going to get H1 is equals to d tan theta 1. If you are shifting the instrument to the next thing, and we are going to take the triangle O2AF, okay, we are going to get a value of H2 is equals to, right, H2 is equals to dd tan theta 2. Okay, so now by subtracting equation 2 from 1, okay, by subtracting 2 from 1, right, so what we will get? we will get h2 minus h1 na? So what is that equals to? That is equals to yes. Okay, that is equals to yes. We will see here h1 minus h2. Okay, that is d tan theta 1 minus d plus d tan theta 2. Okay, so if you are simplifying this already we know we are going to substitute as a yes. Okay, then d tan theta 1 minus d tan theta 2 minus d tan theta 2, small d tan theta 2, right? So now this will be taken out, the d will be taken out from this. Okay, so d into tan theta 1 minus tan theta 2 minus small d tan theta 2, right? So now from the here s will be sent to that side and this brought to this side. Finally we are going to get d, capital D into tan theta 1 minus tan theta 2 is equals to s plus d small d tan theta 2. Okay, now from this equation we can find out the d value. Okay, that we got it as like this. Okay, so now but h1 is equal to how much in this equation? Okay, so h1 is equals to d tan theta 1. Okay, h1 is equals to d tan theta 1. Okay, so finally, right, we are going to get the right. So finally we are going to get this value and okay. So finally RL of f is given is equals to R of benchmark plus S1 plus H1, right? So H1 will be equals to d tan theta 1, right? D tan theta 1 instead of d we are going to substitute this value. Okay. So this is the case 1 in the second thing. And next B case, the instrument O2 is higher than O1. Okay. So here you can see O1 is higher than the O2. Okay. So you can see here from here theta 1, here theta 2, difference between these two small d and this will be capital D, right? We have S1. Okay. In the case of this is S1, this will be S2 and H1 and H2. Okay. So same procedure will follow. So the difference between those two is S, and from triangle 1 H1 is equal to d tan theta 1, and from triangle 2 we got d plus tan theta 2. Both are the equations. Now subtract from 1 and 2, we are going to get same solution, right? So from here the SV is equals to calculated, and from finally we are going to calculate the D, and final RL of F is equals to RL of benchmark plus S1 plus H1, but H1 is equals to how much? D tan theta 1. Here instead of D tan theta, D value we are going to substitute that equation, and finally we are going to get the RL of F, right? Next, case number 3, right? Case number 3, base of the object is inaccessible, right? Base of the object is inaccessible, but the instrument station and the elevated object are not in the same vertical plane. See, observe here, the instrument station and elevated object, right? This is the elevated object and the instrument are not at the same vertical plane. They are not at the same vertical plane. See, this one is here, this one is here. Okay, some other side we are moving. Okay, not in the same plane. Okay, so you can see here the instrument is not in the same line. This is one station, other point we are going to take, not in the same line. Okay, okay, now this is the case. Okay, how to get the values? Okay, now at station 1, that is O1, we took the reading on benchmark and it is noted down as S1, right? So now see, you can see, right? If you are seeing the sighting the instrument, but we are not accessible to the base. Okay, not accessible to the base. Okay, normally in the previous class, some case here it is going to intersect, but it is not there in this case. Okay, so if case is like this, what we have to do, right? So it is the horizontal plane, it is not in the Object gets somewhat high, right? But you are seeing here only. You are going to get here only. You are not citing the object. If this is the case, how to take the levels, right? So now from O1, right? So you are going to take a point A1 here, right? You are going to sight towards it. Okay? You are going to get a value of some theta here, and we are going to sight the F. We are going to get the theta 1, and the height is calculated h1, and you shifted from this location to another location having a horizontal distance of small d, that is point to O2. If you are measuring this is back to the benchmark, you are going to get S2 value as S2. Then if you are sighting towards the same line, it is gone up to A triple dash. From here, if you are sighting the F1, you are going to get a value of theta 2. Okay. So if this is the case, here what you are going to see now? So this shifting of instrument is going to form a triangle like this. Okay. So from this triangle you are going to solve, and finally you are going to calculate the RL of F. RL of F, it is a level of a point F. We will see how it is calculated. Okay. Now from the triangle O1, O2, A. Okay. So now you can see here O1, O2, A. Okay. Right. O1, O2, A. This is the triangle. Right. So from here, if you are taking the angle, that is O1, A, O, right? So that will be equals to 180 minus alpha plus beta. Okay. So and we are going to equating it as theta value. Now we are going to apply a sine rule here, right? Sine rule means the distance by angle, okay, of one side is equals to distance by angle of opposite side. Okay. Now distance into the side. This is the side now. Suppose this is the alpha, beta, and theta, right? So if you are taking this is O1, O2, right, and this is as A dash. Okay. Now you can see here O1 by O2, O1, O2, opposite which angle is there? Theta is there. So sine theta. This is equals to, now we are having O1, A1, O1, O dash, A dash. O dash, A dash opposite is sine beta. Okay. Sine beta. This is equals to next, this one O2, A1, opposite angle is this alpha. So sine alpha. Like this, the equation is derived, right? So now from here you are going to take this O2 A dash. Okay. So if you are sending the sine alpha to that side, so finally it will become O1. Now, so we are trying to do this one, right? So O1 O2 sine alpha divided by sine theta. So O1 O2 will be equals to D. Okay, the shifting instrument from point 1 to 2, that is equals to D. That's why it is equals to D sine theta divided sine alpha divided by sine theta, right? So now like this same thing, O1 A dash will be equals to same D sine beta divided by sine theta. Okay. Next, now H1 is equals to how much? Okay, H1 is equals to A double dash F, right? H1 is equals to H1. This is the H1 na, right? So here we have A double dash. What is this height? That height will be given by, right, A double dash O1 tan theta 1, right? So here this will be written as A dash O1 tan theta 1. Why? Because these two values are equal. Okay. Now H2 will be equals to, right, A triple dash F. Okay. So F is given as O2 dash tan theta 2, right? So this will be written as A1 O2 tan theta. Okay. So we will see how it is equal. A triple dash O1 and A triple dash O2. Okay. How it is equals to A dash O1 and O2, right? A double dash O1 dash. You can see A double dash, A double dash. This is A double dash is this, Okay, from A double dash to A double dash to O1 dash, right? So here A double dash to O1 dash. Okay, this will be equals to how much? Okay, so he is telling A dash to, okay, here A dash to O1, right? A dash to O1. This is the, okay. So ఇక్కడ నుంచి ఇక్కడికి ఎంత ఉందో, ఇక్కడ నుంచి ఇక్కడికి ఎంత ఉంటుంది. Then same thing. A triple dash O2 is equals to, okay. A triple dash O2 is equals to this thing. Okay. So now this one, this line are equal. That's why he took it as those things. Okay. So now we derived finally this. Now RL of F is equals to RL of benchmark plus. Okay. If you are seeing here RL of benchmark. So RL of benchmark is this. Okay. Over here. Okay. If you are adding H1. Okay. So you are going to get the value, right? You are going to get the value. Okay, we need to add this S1 also. Okay, now that will be equals to RL of benchmark plus S1 plus, okay, S1 plus H1. So that H1 is equals to how much? H1 is equals to A dash O1 into tan theta, right? So now we need to derive that one. A dash O1 is equal to how much? A dash O1 is equals to this one. Okay, d sin beta divided by sin theta, right? Sin beta, d sin beta by tan theta, and we will have the tan theta as usual, right? So otherwise we can calculate the other value, that is RL of Bm, right? S1 plus H2. H2 will be equals to how much? D tan theta. So that will be equals to d sin alpha by sin theta tan beta. Okay. So either using this equation or this equation, you are going to find out the RLs of point F. Okay. So these are the things about the trigonometric leveling. Okay. In the next class, we are going to see the problems, how we are going to calculate those values. Okay. So in this trigonometric leveling, we are going to take the angles and the horizontal distance, and we are going to find the vertical elevations. Okay, that is called trigonometrical leveling. Okay, here we have some two cases where the objective base is accessible, and sometimes due to river or any pond we are unable to reach there, and we are unable to calculate the d value. But d value also will be calculated by taking unknown reading, right? One more theta value. Okay, based on that we are going to calculate theta and as well as the H. Okay, so in all these cases we are going to use the instrument called theodolite. In everywhere in the trigonometric leveling, so we are going to use the instrument called theodolite, and finally we are going to find out the reduced level of a object, not called as F or Q or anything, whatever may be the thing, the formula will be the same, right? So this is all about trigonometrical leveling. Thank you.